Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we're going to be looking at the topic acid, bases, and salts. And our subtopic for today is solubility curves. So we're going to look at the first part of solubility curves and questions, and then the second part will actually draw those curves. So we look at what solubility curves are and what are some of the things that we determine in a solubility curve. So one of the factors that affect solubility is temperature, as you can see even from the definition of what solubility is. So for most salts, solubility increases with the increase in temperature. This is because of the increase in kinetic energy. So the momentum or velocity of the solvent molecules or particles increases very gradually so that they can disintegrate the solid molecules more effectively. That's the reason why the solubility increases with increase in temperature. There are other salts which reduce their solubility with decrease in temperature. So this is because increase in temperature causes, especially like gases, the gas molecules to expand and hence escape from the solvent. So some cases where solubility of gases decrease with increase in temperature, that is the reason why. So when we talk about solubility, we represent this information in a curve known as solubility curve. The graph of solubility against temperature is called the solubility curve. So from the word, you know it's a curve. It's not a straight line, it's a curve. And then it shows the influence of the temperature on solubility of different substances. This can be in solids or salts. Some substances dissolve more with increase in temperatures, while others dissolve less with increase in temperature. We have just discussed that. So if you look at the graph that has been shown, you can see solubility in water and then against temperature. This is temperature. So if you look at like potassium nitrate, as the temperature increases, so does the solubility. What you do just interpolate using dotted lines. You notice you can be taught to study a graph, so you need to be able to know how to study. So if you were to look at two values, maybe this will be a temperature 1 and temperature 2, and then this will be mass of water 1 and mass of water 2. So if you look at the temperature, when the temperature increases, so you notice also the mass of the solubility also increases. You can see that. So that tells you that potassium nitrate, the solubility of potassium nitrate increases with increase in temperature. Same case applies with potassium chlorate. You can see with increase in temperature, so does its solubility increase. This is different from sodium chloride, which goes in the opposite direction. So as the temperature increases, you can see the solubility is going downwards. So solubility of potassium nitrate and potassium chlorate increases with increase in temperature. Solubility of potassium nitrate is always higher than that of potassium chlorate at any specific temperature, and solubility of sodium chloride decreases with increase in temperature. And then sodium chloride has the highest solubility, you see, at very low temperatures, while potassium chlorate has the lowest solubility at low temperature. So it goes in opposite. You can see at 0 degrees, that's when sodium chloride dissolves the most, and you can see the solubility goes down at high temperature. Same case with potassium chlorate. You can see at high temperature, the solubility goes very high, and then at the lowest temperature, stand when it has the lowest solubility. And then at point A, as you can see, this point A, both sodium chloride and potassium nitrate are equal in solubility. You can see this is where the intersection is. And then at point B, that's where both sodium chloride and potassium chloride are at equal solubility. area above the solubility curves of the salt shows a saturated or supersaturated solution. So you can see this area above, for example, for the nitrate, this shows the supersaturation, and then the area below it shows the unsaturated solution, like for example, for potassium nitrate as we are shading it. So for salt whose solubility increase with increase in temperature, they form crystals. Crystals form when the solution at a higher temperature is cooled to a lower temperature. So you can see like potassium nitrate, you can see how its solubility increases with increase in temperature. So if you lower the temperature, it means it's going to crystallize some of the solid that had initially dissolved at a higher temperature. And then for salt whose solubility decreases with increase in temperature, usually crystallize when the salt solution at a lower temperature is heated to a lower temperature. So similarly, you can see for sodium chloride, as the temperature increases, solubility decreases. So if you cool, it means as the solubility will increase. So let's do a few examples. So the solubility of potassium chloride at 100 degrees Celsius is 60 grams per 100 water. What mass of potassium chloride will be deposited at 75 degrees Celsius if the solubility is at 39 grams per 100? So I want you to note the initial solubility. So initially, we have 60 grams of the potassium chloride in 100 grams of water. So this is where we are starting from. And then if we cool this solution, its solubility at 75, so at 75 degrees Celsius, it becomes 39 grams of potassium chloride in 100 grams of water. So you see the mass that can be dissolved in the water decreases gradually. So it tells you not all the 60 grams will still remain in the water. Some of them will crystallize out. So what you are going to do, you subtract, you say 60 grams minus 39 grams, which will give you 21 grams. So 21 grams of the potassium chloride is the one that is going to crystallize out. So next, so the same in at 35 degrees Celsius if the solubility is 28 grams per 100. So we start again. So initially we had 60 grams of potassium chloride in 100 grams of water. So now we add, if it's cooled at 35 degrees Celsius, it becomes 28 grams of potassium chloride in 100 grams of water. So if you want to see how much salt cooled, you subtract. So it is 60 grams minus 28 grams, which gives us 32 grams. So this is the 32 grams of potassium chloride. So let's do one more question. Potassium nitrate has a solubility of 42 grams in 100 grams of water at 20 degrees. So let's note that down. At 20 degrees Celsius, solubility is 42 grams per 100 gram of water. The salt was heated and added 38 grams more. So it was heated and it was heated to 100 degrees Celsius and then added 38 grams. So which dissolved. So this 38 grams dissolved at 100 degrees Celsius. Calculate the solubility. So this is very direct. So we started with 42 grams initially. We added 38 grams. So let's see how much we are adding up with. It will give us 80 grams. So 80 grams of the potassium nitrate is the one that will dissolve in 100 grams of water. So we don't need to do any more calculation because we've just been asked to calculate the solubility. So the solubility will be 80 grams per 100 grams of water. And that will be our answer. So that concludes this part of the session. So you can see how you can use the graph. Sometimes you can be given a graph, as we are going to see in the next lesson, and you draw the graph and then you use the graph to do questions. So we are going to do that together and see how that is done.